The subject EC 8691 Microprocessor and Microcontroller. Shortly it is called as MPMC. So in today's session, we are going to just to see the introduction part, how this MPMC is related, and what is that you are to study, and at the end of the course, what you will be knowing. Okay. So first I'll go with the course objective. So what is the course objective of this subject, that is 8085, or it starts with microprocessor. Let me say it simple. So course objective here is to, this is given by the Anna University syllabus, right? So based on the syllabus, this course objective is given here. So for each unit, they will be given an objective, and each unit, at the end of each unit, you will be able to study something which will be useful for your career in future or at the end of the course, right? So first point here is to understand the architecture of 8086 processor. Understand the architecture of 8086 processor. And second objective is to learn the design aspects of I/O and memory interfacing circuits. So how will you learn and design? So after learning, it doesn't stop with learning. You have to design the I/O interfacing and memory interfacing circuits. So first you will study what is a processor, and then you will be designing, and you will be implementing through interfacing with the particular processor and getting the output, right? And third unit is to interface the microprocessor with supporting chips. So what are the applications you are going to see by interfacing, by connecting these processor with this I/O or any other memory interfacing circuits, what it will give, with the help of the supporting chips. And to study the architecture of microcontroller. Since your subject name is divided as microprocessor and microcontroller, the syllabus is planned in such a way, you start with the microprocessor and then the flow goes for microcontroller. So we'll start with this processor. So they have given directly with 8086 processor. Actually, the earlier 2013 regulation or 2008 regulation papers included 8085 microprocessor as the first unit. So it is the simplest processor, and it is an 8-bit processor which will be processing the data based on the 8-bit data, right? So here you are going to study about the 16-bit processor, which is the next development of this 8085 microprocessor, which came into the industry, right? So fourth unit is to study the architecture. So as you study the architecture of microprocessor, the first part, the second half is with the microcontroller. So you need to know the architecture of this microcontroller. So the basic microcontroller, or the basic controller which you should know before going into the advanced technology of all those controllers which is available now, you should know about this 8051. So before learning all these letters or whatever sentences, words, you will be learning in pre-KG what is alphabets, A for apple, A, B, C, D. So here also the basics only you are going to study. So with this course, you will design, you will think about it. This is the basic of the processor level and the architecture concepts, how it is interfaced, how it can be designed to give an output, right? So last unit is to design the microcontroller based system. Actually the same concepts. So whatever the architecture points you have studied, you will see what is the design part of this microcontroller. So here our aim is to frame with the objective, stick on with the objective. So after my teaching, so what happens here, once again, after my teaching, what happens with the outcome? So at the end of this course, after each and every session, your outcome should be a better understanding of the topics, whatever I cover day by day. So at the end of the course, you will have a fruitful outcome which will be useful for your career. Okay. So the course duration they have planned for this subject is given here. So usually it is divided in terms of a lecture, that is in the top right corner you will see in the syllabus LTPC. So it is denoting the lecture, tutorial, practical, and course hours per week, right? So you could see here the subject code EC8691 MPMC. The total lecture hours planned will be 3 hours per week. So if it is an offline class, you will be utilizing total 1 hour, whereas in a pandemic this hour you will be utilizing 50 minutes, right? So based on that, the hours will be changed. Either it will be 5 hours per week. It changes, right? So to compensate those 10 minutes, it is given, and the total course hours. So we are not going with the tutorial, and we are not going with the practical for this particular subject. So 45 hours we need to cover when it is an offline duration. So now coming to the syllabus flow. So what is the syllabus and how it is carried, we will see. So at the end of this class, before it ends, I will show you all those understanding, that is which will kindle your interest towards this microprocessor. Okay, am I reaching you people? Is it clear?
Yes, ma'am. Yes, ma'am.
Yes. Thank you, Raja. I think it is Raja.
Yes, ma'am.
Yeah, thank you, Raja. So introduction, the first topic here is with the 8086 microprocessor. So what is the processor we are going to study? So we are going to concentrate with this only 8086 processor. So under that we are going to see introduction to microprocessor and 8086 microprocessor architecture. I don't want to take much time on this. I will explain each and everything with respect to the flow of this syllabus, so that it will be a better understanding. Either time waste just to go through it. It is the addressing modes of 8086 microprocessor in order to know the instruction sets of 80. So before going into all these topics, you want to know why the syllabus is given like this. Okay, so that I better now I skip all these points, and then I'll come to this back. So 5 units, how they have comprised, I will come to it later. Because before going into the subject, you must know why you study the subject. So what is the picture showing? It will be easier for you. Yes. So bus is a thing, or we can say it is a facility which takes the passengers from one place to another. Okay. So if a passenger is standing alone, he doesn't know where to go. He doesn't know where to go or his destination, then he will be lost. Am I right? So the same analogy you consider here. So when you go into this processor, microprocessor, the terms used, which is repeatedly used here, is bus and interfacings and datas, address, etc. Are you clear? So in order to make you better understanding, I am showing you this. So what is buses? It carries the passengers from one location to another. So in terms of microprocessor also, there will be a bus terminology used where it is divided into three. So first one is the data bus. Okay. First one is the data bus. And what is your second one? It is the address bus. And third one, it is the control bus. Okay.
Data bus, address bus, and control bus.
Very good. Data bus, address bus, and control bus. So what is the use of these buses? So you can compare this analogy with the term which I am going to use here. So what does a bus does? Bus carries passengers from one location to another. So here I have captured one picture which shows it is from Mukkadam to Somanur. Okay, so since we are from Coimbatore, I have taken this example. So from Mukkadam to Somanur, this is the route, main route. Via this route, it carries with Nilambur or Aerodrome, CMC, etc. Whatever the routes it covers, it is different. So you can't define a people where he is getting in will get only at Somanur. So his destination, when he is arriving at his destination, he will just get down. Am I right? So as such, I am considering this data bus comparatively to the passengers. So passengers is nothing but the data which is loaded in the bus. So analogy. So in terms of another example here, a letter. A postal letter I'm considering. So what is the postal letter? So postal letter is nothing but the letter which is the content or information written here will be your data. Okay, will be your data. Are you relatively comparable to the data? What is I'm trying to say? And what is your address? Address is nothing but each and everyone will have some destination to be reached from the source to destination, right? So a letter இருந்துச்சு அப்படின்னா அவங்களுக்கு sending address கண்டிப்பா தேவை இல்லையா? So from address to address is essential here. So the content which is inside this letter, that is the data, will be carried by this address bus from one place to another. Are you clear? What is this address bus role? So data bus is nothing but it is just the information, and address bus is nothing but it shows the location where this data is to be transferred or delivered. Are you clear? And what is the role of this control bus? Can you tell me the role of this control bus from the view or whatever I'm showing here? So without the control or the driver, let me take the example here, the driver. So what does this driver does? He is the responsible person to carry or to drive this bus from the source to any other destination. If he is losing his control, what happens? There will be accidents. Am I right? Whereas in terms of postman, if the postman is not properly doing his duty, whether this delivery of letters will be transferred from one place to another? No. So this is the role of the control bus. So the control bus only gives the control he gives the driver from where the source has to be started to where the destination has to be received. So through this control only, the passengers, that passengers are carried through this bus and delivered to the particular address. Similarly, the postman, looking into the address which is written on the envelope, he carries the letter, that is the data, through to the address. So the control is here. So what is simply in terms of control bus? Control bus, without the control bus, the data and the data cannot be delivered to the particular location. Are you clear? Are you clear with the analogy now?
Yes, ma'am.
Yes. So now a simple example for our day-to-day life. So the last here is nothing but which you cannot comparable with the technological part. Okay. So this is just an identification. இது நீங்க வச்சிருந்தா கண்ட்ரோல்னா என்னன்னு சொல்றதுக்கு உங்களுக்கு ஒரு ஞாபகம் வரணும் இல்லையா எக்ஸாமுக்கு, அதுக்காக நான் சொன்னதான் இந்த அனலாகி. நீங்க போய் அங்க போஸ்ட்மேன் எழுதக்கூடாது. Whereas here you could see the example through the mail. Okay. So what is it? So here you could see through the example that a mail, which is an email, right, which is delivered from one person, okay, to all these follow members, right? And what is the content of the information delivered from her to us? It is the data which carries the nominal role of third CSE B. Since she is the advisor, she has mailed the data to all the class handling faculty. So we are the recipients, and who is the sender here? Your advisor is your sender. Okay. So how this is carried? This is the address. So where is the source? This is the source location. What is the destination location? This is the destination location. Okay. What is the data delivered? This is the data delivered. And what is the control here? So whenever she clicks the send button, it takes the control and it delivers the data. Are you clear? So this is just a simple analogy example I can give for this data bus, address bus, and control bus. So earlier, without the introduction of these integrated circuits, how the connections was established was given or shown here. So this is a simple circuit versus a complex circuit. So you could see a simple circuit which shows the glowing of bulb. By connecting a switch to a battery of 5 volt or 10 volt, you could make a simple LED bulb to glow. So this experiments you might have tried in your school level projects itself. So this is a simple circuit I can give as an example. So how this connection will be established is the secondary part. So can you see this complex circuit which is shown here? So this is the circuit diagram of a recorder. It is a circuit diagram for a recorder which consists of numerous transistors, okay, numerous transistors, resistors, inductors, capacitors, diodes, etc. So I hope you people haven't forgot that BWME class. Okay. So BWME class, the very first unit which you have studied is solving all these circuits to give you a better output. So you started with the finding out the Thevenin circuit, which resistance will be better for the circuit, which voltage will be better for any circuit. All those things you have studied, and that is the basic knowledge you know about these circuits. So where these circuits? So before looking into the output picture, whatever you are in front of the gadgets you are having, all those things will be having such types of circuits. So where these circuits are essential in order to build a type, that is output or device, a prototype. So prototype is nothing but an analog which shows this is a model which can give an output like this. But going for the real world scenario, you are having a handheld device called mobile. So inside mobile, have anyone checked out what is inside a mobile phone? So it will have an IC with all those devices. You will have an on off switch. In order to control your volume, you will have a side button. You will control your volumes, you will control your brightness. So everything now is made as a touch screen model. So touch screen model, what is that? It is an LCD display, right? It is a display device. How the display is understanding the input in terms of sensing the touch, right? That is the input. Before that, it was like switches. So keypads were used. How these keypads will give the input and it will produces the output, right? So these are the analogy you should understand where you use or study this subject. So this is the complex circuit. So you can understand how you could give this. So instead of this huge or heavy recorder circuit diagram, if there is a simple IC which gives you with a 8-pin configuration, first pin if you give this as supply, second pin if you give the input, input kuduthingana and the recording output vandrum. That's all. How it is made simple? Only because of this IC. So how we get this IC? So in order to know how these ICs are got, so this is all irrelevant to your subject, but it is somehow related to the subject what you are going to study, why you study this subject. So you must know it. So you have heard about the Silicon Valley configuration, Silicon Valley, right? Now also there is a demand for all these silicons, right? Right now, and it is deteriorating, right? It is getting depleted. So how these silicons are to be manufactured? So usage of these ICs which needs silicons. So silicon is much needed for the industrial development as well as industrial in the sense technological development. So how these ICs are got? So this is about the silicon rod. Okay, this is the silicon rod. Grow some crystals. That crystals turns into a silicon ingot. Those silicon ingots are sliced. Sliced means it is cut. Okay, so it is sliced means like slicing an onion. Your mother used to slice the onion in the cutter, slice potato in the cutter. So a big potato, imagine a big potato which is sliced to lace chips. Okay, so likewise here also that ingot of silicon is sliced. Okay, and that wafer, one slice of it is called as a silicon wafer, that is oxidized. to a furnace. So that furnace will give you an oxide coating which converts into a silicon dioxide. So after that, all those the masking, edging process is done here. So this is the silicon which is oxidized silicon which has a layer over it, and here the resistive material is coated. So what is the resistive with that? It depends on the photoresistive material to be used, because we are going to mask and pass the lights through it. So எந்த ஏரியா உங்களுக்கு வேணுமோ அந்த இடத்துல I want some transistor to be implemented on this, then I will oxide this, and what happens here is we will go for the masking of that particular area, and we will ingot it, that is we will pour some material, that is resistive material, over it, and in that way the process gets repeated for a particular circuit, and finally you will get the ICs. So this is the IC we will get. So after several process only, you are getting a minute IC which consists of several number of transistors, that is active devices as well as passive devices in it. Are you clear? So you know about the active and passive devices. So in a single IC, instead of you have done the lab in electrical circuits lab. You are aware of it? We have carried some experiments in the second semester. Lab ஞாபகம் இருக்கா? வந்து CRO ஃபங்க்ஷனாலிட்டிக்கு எப்படி ஐசிக்கு இன்புட் எங்க கொடுக்கணும், அவுட்புட் எடுத்தீங்க இல்லையா? ஸோ அதெல்லாம் தான் நீங்க ரீகால் பண்ணணும். ஸோ என்ன பண்ணுது அந்த ஐசி? ஜஸ்ட் இன்புட் வாங்கி அவுட்புட் கொடுக்குது. ஸோ அதே ப்ராசஸை இதே நீங்க வந்து எக்ஸ்பெரிமெண்ட்ஸ் பண்ணும்போது பிஎன் ஜங்ஷன் டயோடோ இல்ல நம்ம பண்ண அந்த ஆஃப் வேவ் ரெக்டிஃபையரோ என்ன பண்ணோம்? சர்க்கியூட் டயக்ராம் இந்த மாதிரி கனெக்ஷன்ஸ் கொடுத்தோம். எதுல கொடுத்தோம்? பிரெட் போர்ட்ல கொடுத்தோம். ஆர் யூ கிளியர்? ஸோ இந்த மாதிரி பிரெட் போர்ட்ல கனெக்ஷன்ஸ் கொடுத்துருப்பீங்க. am I right? So you could see if there are circuit, இப்போ இந்த மாதிரி சர்க்கியூட்ஸ் யோசிக்க, இவ்வளோ பெரிய சர்க்கியூட் இருக்கு, எத்தனை ரெசிஸ்டர் எத்தனை கெப்பாசிட்டர் இருக்கு நீங்களே பாருங்க, இங்க எல்லாம் பாருங்க. இட் ஹாஸ் அட்லீஸ்ட் இன் திஸ் ஏரியா இட் செல்ஃப் விச் ஐ எம் ஷோயிங் ஹியர், இட் ஹாஸ் சம் 7 transistors. Is it possible to pull all those transistors in this breadboard? It is highly impossible. So only the technological growth enhanced this IC. So with the use of this simple IC, நீங்களே பார்த்திருப்பீங்க, simple ஒரு IC யூஸ் பண்ணி connections establish பண்ண முடியும். So இதை நீங்க இப்ப நான் இவ்வளவு தூரம் சொன்ன processor, you could see how this is shown or how this happens in real world. If you want, you can browse and see. This is the silicon ingot which is manufactured, and it is sliced. You could see the sliced structure. After that, it is polished. Mirror polishing is done. That is silicon wafers. And above that, an oxidation coating is done. And after all those ingot or whatever the process here, etching principles, you will finally get this. So you could see here, there is this several number of sections. So you could see from each one section, it will have the numerous datas. Okay, that is the concept here. Are you clear? So from this silicon, which is a big size with the diameter, which will be reduced into a minute size. So this is the IC preparation. So you could see here, finally, one single this chip will be carried to the IC. That is the packaging. This is the final package you will arrive. So this is the structure which is taken from this. So எனக்கு இந்த பார்ட் மட்டும் போதும் அப்படின்னு நினைச்சிட்டீங்கன்னா, எனக்கு இந்த ப்ராசஸர் இப்போ 8086 ப்ராசஸர் வந்து இந்த ஐசியில் இங்கே நான் பில்ட் பண்ணியிருக்கேன்னா, அதை வந்து ஐசி ஃபார்மேட்டில் இங்கே பாருங்க 20 சென்டிமீட்டர்ல இருந்தது எவ்வளோக்கு வந்திருக்கு? 15 millimeters குறைஞ்சிருக்கு. So the size of the circuit is also reduced. Finally, the packaging is done. So நமக்கு நீங்க இதுதான் பார்த்திருப்பீங்க. ஸோ இந்த ப்ராசஸ்ல ஐசி பேக்கேஜிங்ல இவ்வளோ இருக்கு. ஸோ இதை தான் நம்ம ப்ராசஸராக யூஸ் பண்ணுவோம். ஸோ இது நம்ம சொன்னோம் இல்லையா, பில்ட் பண்றது, சிலிக்கான் டை ஆக்சைடு யூஸ் பண்றது, ஒவ்வொரு இதுலையும் லீட்ஸ் எடுக்கிறது, எல்லா ப்ராசஸும் இதில் நடக்கும். Are you clear? So this is the example where we use it in our laboratories. How we use this? Okay, and you can see the PCB in a circuit design. So what is PCB? So PCB is nothing but a printed circuit board, which will be useful for you to design aspects. நீங்க இந்த சர்க்யூட் எல்லாம் டிசைன் பண்ணிட்டீங்க, சிம்பிளா இந்த சர்க்யூட் போட்டீங்க. ஒரு ரோல் இப்ப நீங்க எந்த ப்ராஜெக்ட் எடுத்துக்கிட்டாலும், மினி ப்ராஜெக்ட் ஆனாலும் சரி, மேஜரா நீங்க கம்ப்யூட்டர் சயின்ஸ்ல முடிக்கிற ப்ராஜெக்ட்னாலும் சரி, ஒரு ப்ரோட்டோடைப் சொல்றீங்க. அந்த ப்ராடக்ட் எப்படி கொண்டு வர முடியும்? only with the hardware components. So in order to know this hardware components only, I'm giving all this introduction to you. So you must be aware that. So coming to our topic, what is a processor? Can you relate this diagram and tell me what I'm trying to say? What is a processor? From the name, can anyone tell me what is a processor?
Doing number of works.
Yes, doing multiple works. Very good. One answer, that is better. Okay, so you could see here, process means it is doing something. So processor is a device which is enabling that process to carry on. Okay, so here also I could relate this. A mother, she is playing a role of a homemaker and she is a working woman. So what is the role play she does play? She needs to take care of her kid, keep the home neat, and she need to look after the homeworks, right? Any other notifications to be carried in the home, functions to be carried on, everything will be carried on by her. So she process all these data in a, or this works in a magnanimous way we can take. Okay, so if it is not in an organized way, then it will be in clumsy, or you can say it ends up with the huge number of works. So this is an example for multi-processing, as one of your fellow mates said. So here, since not only women, men are also performing multitasking, who will take care of his family as well as with the workspace. So could you tell what is a processor? Processor is nothing but which process the information based on the operations given to it. So here you could compare this analogy like it. So now coming into the real picture of what is our topic, 8086. So 8086, as I said, it is available in a 40-pin configuration, right? By this processor. That is, this is a company which produced in the year 1978. So the copyrighted by Intel in the year 1978. Whenever you look into an IC, you will see a tip mark which is used to note down which pin should be considered first and what is the last pin. So carrying from the dip mark, it should left side, it carries from 1 to 20 pins, and here 21 to 40 pins, right? So this is about the 8086. Whenever you can look into the IC, by looking into this, you will clearly tell what is that IC. Okay. And it is a 40-pin configuration, as I said. So what are the configurations, what are the pins it has, will be explained in the coming up classes. This is just an introduction. And how this 8086 is available in our lab. This is shown here. So how this 8086 supplied by one of our company, that is VI Microsystems, is a 16-bit microprocessor trainer, right? This is the IC, either this or this. It is an IC and it has an LCD display, and switching on, interfacing cords are available. And here you could connect with the keyboard and you can train it, or you can produce as the output. Are you clear? So this is the setup. You will see the 8086 in the lab. Okay, best interfacing examples. So now coming to the interfacing concepts. So what is an interfacing is nothing but we are going to connect this processor, okay, with the outside equipment by means of some cords, cables, to produce our output based on the program you are going to feed in. Okay, so first example, a best example is a traffic light controller, which you will see in a day-to-day life. So from the server through internet, some processing is done which controls the traffic light. So this is the traffic light pattern which is available in the trainer kit, which you will see in the lab experiments, right? And what is the language between this designer program. So you need to know how this machine understands. So machine in the sense here the processor, how it understands based on the programmer or whatever the designer is doing, right? So by means of coding, actually this coding in this processor, this language is called as assembly language programming. So what is the programming known for this processor is assembly language programming. So Python programming and மாதிரிலாம் இருக்கு இல்லையா? So இங்க ப்ராசஸருக்கு நீங்க என்ன ப்ரோக்ராமிங் யூஸ் பண்றீங்கன்னு கேட்டா நீங்க என்ன சொல்லணும்? We are using assembly language programming. For that particular coding will be there, we'll study, and we'll for this coding we need to know what are the instruction sets, what are the instructions to be given, etc. Okay. So we'll study about the controllers too. So controllers in the sense it is all different from each one. So you could see this is, can you guess what is this? Can you guess what is this? Or can you guess what is this minion? What is minion does? It will always disturbs, right? Or interrupts. Okay, so there are different types of controllers you need to know. First one is the memory access, that is direct memory access. So the memory is open where they can directly access it. So direct memory access. And interrupt controller, types of controller, alarm controller, keyboard controller, display controller, and conversion factors controller, that is analog to digital or digital to analog converters. Okay, so there are different types of controllers. Again, an application part, we go for traffic light, we go for stepper motor controller, and we go for communication devices. Okay, serial to parallel or parallel to serial communications to be established. So now coming to the syllabus. Okay, so what does the first unit does? It gives you the introduction to microprocessor. What is the architecture? So what is the architecture means? What is the building? How this architecture is built on? Okay, for that, next is we will go with the addressing modes. So where and how this addressing is done, addressing modes, instruction sets for programmings, and assembler directives of the 8086 processor, where it should be directed. Then we want to know about the programming status of this 8086. So assembly language programming. What is modular programming? What is the concept of linking and relocation? So there are different steps to be carried when we consider with programming, and what are they? Modular programming. What is the need for stacks? What is the need for procedures? What do you mean by macros? And what are the interrupts? Interrupts means I'm taking a class and somebody is interrupting me. So that is an interruption. So also here, while running a program, in between, if the program is stuck or interrupt can be done by any other devices by means of enabling a interrupt control. What is that? So what is the use of that interrupt service? So if we keep on running a program and it takes for hours and hours, that is useless. If you want to run or stop a program in between, it should be enabled. So how that can be done? Then byte and string manipulation. Okay, all this in first unit you will be knowing. So in second unit, you will go with the system bus structure, where you will study about the 8086 signals, basic configuration, system bus timing, system design using 8086, and I/O programming. So how these ports are enabled, input and output, introduction to multi-programming, and what is the system bus structure, multiprocessor configuration, coprocessor, and closely coupled and loosely coupled configurations. And next is with introduction to advanced processors. So there are different levels of processors available. Now we are talking about the ARM processor, Arduino, which is useful in IoTs, etc. These are all the advanced levels. So before going into that, you need to know what is a processor. That's what you are studying this subject. So memory interfacing and I/O interfacing, what is the use of it? Parallel and serial communication interfacing. So after establishing the ports, you will go for the interfacing devices as I shown, ADC or DAC, timer, keyboard, interrupt, minions, what I have shown, DMA open with memory, DMA, direct memory access, and with the study case study application includes traffic light, LED, LCD display, keyboard display, alarm control. So are you clear with the pictures what I have shown? And last with you go with microcontroller. Similarly, with the controller topic, what is the architecture, what are the registers, what are the pins, ports and functionalities, what is the instruction set for this controller, what is the addressing modes and assembly language programming. And finally, with fifth unit, how we are going to interfacing the same controller. So same concept of serial, interrupting, LCD, keyboard, ADC, DAC, sensor, memory, stepper motor, and all these are done. Finally, we'll study the comparison of all those things, that is a processor with a controller, the advanced PIC microcontroller, and ARM processors finally. Are you clear with the flow of the syllabus? Yes or no?
Yes, ma'am.
Yes. So at the end of this course, what you will know after this course is over for this semester, you will understand and execute programs based on 8086 microprocessor. You will be able to design and interfacing circuits. Either it will be a memory or an IO circuits, and it design and implement using 80851 microcontrollers. So that is the concept. So what is your takeaway points of today's class? Is these questions are fulfilled? Ask yourself, are you able to give the answer for these questions? This is a 3D animation which shows how a computer works. So you know the question for how it is related to your subject, you please think about it post this video.
These are used to store digital data. CD-ROM accesses the data on the CD with the help of laser beams.
So data goes to a particular address location. Okay. This is the data in the CD. So imagine it is a CD which is having datas.
The data on the CD is in the form of zeros and ones.
So how these data are analyzed by the machine? It is in the format of zeros and ones. That's why you study DPSD. DPSD in the fourth semester, I hope. So only in zeros and ones it understands. So that zeros and ones are being gone, or the data in format of zeros and ones are going to a particular address locations.
After the data are read by the laser beam from the CD, they are transferred to the motherboard through the IDE cable.
Let us consider this is a 4-bit.
Our bits are entering the motherboard. The motherboard serves to connect all the parts of the computer together.
So before going into the PC, a motherboard it checks for the security check. Managed.
Not every bit is allowed in the city. Now you see why.
Scanning process happens, which tries to detect the virus and it destroys it.
Bus. Bits will be stored on
So
flash
this is the
and
bus I
transferred to
said.
the RAM.
From one location, it carries to
Bits will
the
be stored
another
on flash,
location.
so CPU can access them faster in order to do the processing.
So how this binary plays a major role in terms of computer machine understanding. Okay, so which is the counting system for a, so for each and every number systems whatever we are using, it goes for coding, which uses the binary number systems. Okay, so in terms of binary only, the computers understand the concepts. So here comes the transistors. For each one of these zeros and ones, this zeros and ones concept, this transistors are involved. So in terms of bits, it is a 8-bit constitutes a 1 byte. So for a 8-bit processor, this is how the 8 bits will be allocated in terms of zeros and ones. So in terms of American, there is ASCII code, all these zeros and one possible values will be converted. So if I want to allocate 82 here, I will go with awning of these switches based on the codings available. So for in terms of ASCII only, for 255, that is 0 to 255, totally 256, there is an ASCII code for each and every numbers, including the punctuation marks and notations. So only we go for this usage of this binary bits. Very clear? Hope this will be useful for this. So when we go for this 8-bit processing, it is least usable. When we go for these 8 bits, an addition process, it goes constitute for 16-bit. 16-bit is also not usable when we go for high-end gaming. So we go for this allocation to 2 power 15. So always bits are increased in terms of numbers. So how this will be done by means of using a multiprocessor. So now we are studying only the basic processor types. Okay, thank you for your patience. Thank you guys, you can leave.